So in this problem, we're given a situation that looks like this. We have a spring scale sitting on top of a frictionless table. It's attached by pulleys to a 20-pound weight on one side and a 10-pound weight on the other. Now, on this side, I'm going to define downwards to be positive, and on this side, I'm going to define upwards to be positive, both along the length of the rope. And I'm doing that because if this mass is heavier than this mass, then this system is going to shift in this direction. This is going to fall, and this is going to rise. Now I'm going to label this mass A and this mass B, and I'm going to skip the isolation diagrams because each block only has two forces acting on it. It's got the force of gravity, and it's got the tension force from the string, and the tension force is equal to the force of the spring in the spring scale. So I'm just going to go ahead and do the sum of the forces on block B right here. Is going to be 20 pounds because that's its weight. Remember, pounds is not a measure of mass, it's a measure of weight. It's the force of gravity upon the block. 20 pounds minus T, the tension force, and that's going to be MA. And then the sum of forces on block A is going to be the tension force minus 10 pounds because the tension force is going to pull it up, and that's going to be resisted by the force of gravity. And that's going to be the mass of block A times the acceleration. And now these two accelerations are going to be the same because the spring scale doesn't stretch and the rope doesn't stretch, which means that the two have to accelerate at the same rate. Now that means that we can just add these equations together and we get 20 pounds, the two t's cancel out, minus 10 pounds equals MA plus MB times A, the acceleration. So then we get the acceleration A is equal to 10 pounds over MA plus MB. And we're going to have to figure out what their masses are based on their weights. So their masses are just going to be the weight divided by G. So we get 10 pounds divided by 10 pounds over G plus 20 pounds over G, which gives us G times 10 pounds over 30 pounds, or G over 3. So this is going to be the acceleration of our system. This block is accelerating downwards at G over 3, this block is accelerating upwards at G over 3, and the spring scale is accelerating to the right at G over 3. Now in part B, we're asked what the spring scale is going to read while this is occurring. And remember that the spring scale just reads the force that it has to apply to both ends. So in this case, that force is going to be equal to the tension force. Because this is a massless, stretchless string, the tension force is going to be constant throughout, and that means that this spring has to apply the same tension force on the right-hand side and on the left-hand side, which is just this T right here. So then we can just take this one equation right here, take 20 pounds minus T is equal to MB times A. T is equal to force of the spring is equal to 20 pounds minus MB times A, shifting this equation around. And so we get 20 pounds minus 20 pounds over G times G over 3. Remember, this is the mass of block B, and this is the acceleration we got at the beginning of the problem. And this gives us 20 pounds minus 20 pounds over 3. And if we multiply this by 3 over 3, we get 60/3 of a pound. And so, subtracting out, we get 40/3 of a pound. And that is exactly the spring force that the scale has to apply, and so that's what the scale is going to read.